A very good morning to one and all. So children, today we are going to discuss next topic of the chapter in which accuracy, precision and error analysis is included. So children, very first we are going to talk about the accuracy and the precision. So in a very simple manner, if we talk about the accuracy, what is accuracy? Basically, accuracy tells us how close a measured value to its actual value or the true value. That means if any physical quantity having its standard value or the measured value or the actual value, and we are measuring that quantity again with the help of some instrument, then some any other instruments, then so what is the difference and how close the measured value with the actual value? Done, children? So basically accuracy is how close a measured value is to its actual or the true value. Then with the help of the example we can understand that actual or the true mass or the weight of the body is 1.25 kg. Then this is done by the standard measurement. Right? Now we are measuring that mass or the weight of the body with the help of the any other instrument, and we measure several times that weight of the body and we calculated the weight of the body in a very first time, that is 1.23 kg, 1.24 kg and 1.25 kg. Right? So somehow these all three measurements are very close to the 1.25 kg. Then children, so this tells us about the accuracy. If measured value is very close to the actual or the true value of the measured physical quantity or any physical quantity, then that measurement is said to be very accurate or approximate accurate. Then next we will discuss about the precision. Now if we are measuring any physical quantity with the help of any instrument, and whenever we are just measuring any physical quantity with the help of any instrument, then we have to done more than 2 observations. Right? So precision tells us about precision is how close the measured value are to each other. Right? How close measured value are to each other. Now we are not talking about the actual value of that physical quantity. We are talking about that how close all the measured value are. Right? That means if we are doing the experiment 4 times and very first we calculated the mass of the body, or we can say the same example 1.23 kg. Then in the second time when we measure the value, this is 1.24 kg. Again if we measure, this is 1.23 kg. Same value we are getting. So 3 times if we done the measurement, the all values are very close to each other. Right? That means our measurement is more precise. Is very precise because all the measured value are very close to each other. Right, children? So this is how precision tells us about the measured value of any physical quantity. That means how those measured value are very close to each other. Right? Now with the help of the example, we can establish a relationship between accuracy and the precision. Then for that, if we are taking one example like this, we are having very first this diagram, and in which diagram, in this diagram we are having a hollow circle, and hollow sphere we can say, and out of these very near to this circle we are having 4 black dotted points. Right? So this hollow circle, this circle represents the true value or the actual value of any physical quantity or any quantity, and these 4 points representing the measured value. So if we see in the diagram, so like above this hollow circle, above, or we can say these 4 points, black dotted points, are very close to this circle. Right? So we can say this measurement is high accuracy and highly precise. Right? Because true value and measured value are very close to each other. Then when true value and measured value are very close to each other, then measurement is said to be highly accurate or high accuracy, of a high accuracy. Now if we see, these all four dotted diagrams are very close to each other also. Then if all the measured value are very close to each other, then that measurement is highly precise. Right? So we can say this measurement is highly accurate and having high precision. Right, children? Similarly, we can see again the next diagram. In the next diagram, you can see that this circle, small circle representing the true value. The true value or the actual value of the measured physical quantity, and these four dotted points representing the four measured values. Then now if you see the diagram and compare it with the very first diagram, you can see all the measured value are very close to the actual value. When measured value are very close to the actual value, that means that measurement is very accurate and having high accuracy. Then right now we will compare these four dotted points which are representing the four measurement done by us. Now these dotted points, if we compare these four dotted points with the very first diagram, so these four dotted points are far away from each other. Then comparing to the first diagram. Now these all four measurements are far away from each other. When they are not, the measured values are not close to each other, then precision will be low. If these are very close to each other, then precision will be high. Now we are having this like this condition. In this condition, all measured values, all measurements are very far away from each other. Right? So this precision is having low. So in this particular condition, we can say the measurement is highly accurate but having low precision. Right? Now we will see the next diagram, that is, in this particular diagram, if we compare it with the very first two diagrams, this hollow circle, this circle, small circle representing the true value. Then and these four black dotted points representing the measured value. Now if you compare the diagram, these four dotted points or the measured value are very far away from the actual value. That means there will be more difference between the actual value and the true value. That means what it means? It means that the measurement done by us is not accurate, is not highly accurate. That means that is having low accuracy. If actual value and measured value are very far away from us, if they are very close to each other, then that will be more accuracy. That represents the high accuracy. Then now, very first thing is that this measurement having low accuracy. Now we will just compare these four dotted points. Now we can see these four dotted points are very close to each other. Then so if measured values are very close to each other, that shows the high precision. That shows the high precision. Right? So that means this observation defines the low accuracy as well as the high precision. Right, children? So these all the things are about the accuracy and the precision. Many more times we have to use these terminology. That's why we have to understand what is accuracy and what is precision. And sometimes we are having the definition of the precision also for a 1 mark question in our exams also. Right? So this is very important for us. Right, children? Now we will move our next topic, that is error analysis, and very firstly we will talk about the errors. So what is error? So if I simply say uncertainty in measurement is defined as the error. So whenever we are measuring any physical quantity and there is uncertainty in the measurement, right? So that may be some error in measurement of that particular physical quantity. Right? Now what is the certain measurement? That means whenever we are having very accurate value of that physical quantity, that is certain measurement. Then there is no doubt in that value. If you are having doubt in any measured value, that is uncertain. And if you are not having any doubt in that physical quantity, that means that is certain value, right? So we can say uncertainty in measurement of any physical quantity is defined as the error, right? Or we can say that, very truly we can say that error equals to the true value minus measured value, or we can say the difference between true value and measured value will give us the value of the error in any measured physical quantity, right children? Now we will understand this terminology with the help of the example. Now if we talk about the example, so we can say if we calculate number of balls in a box. Suppose there is a 10 ball in a box and someone told you to count these balls which are in the box. Then so what you will do, then you will count all the balls and you will tell this will be the value of the ball in a box. Then so there will be, you are very sure about your measurement. Then there is no confusion, no uncertainty in your measurement whenever you are counting the balls which are in the box, right? So number of balls in a box is the certain measurement. Then there is no doubt, right? Now the next thing is that if someone told you calculate the number of atoms in a box. So if someone told you calculate the number of atoms in a box, so what will you do children? So you will do by any very long formulas, with the help of the long formulas, you will calculate the value and you will get the number of atoms in the box like 1.2356 and many more digits are in the measurement, right? So the number of atoms in a box is having uncertain measurement. Somehow we are not very sure about that particular measurement. We can calculate, but that is not very exact measurement done by us, right? So this will be defined as the very first defined as a certain measurement and second defined as the uncertain measurement, right? So this is all about the definition of the error. So error is defined as the, we can say, difference between the actual value and the true value is defined as the error, or uncertainty in measurement of any physical quantity is defined as the error, right? Now we will talk about some types of the error. Right? So according to the experiment, we are having the two types of the error, basically systematic error or the random error. Very first we are having the systematic error. So systematic error is defined as these errors tends to shift result in the one direction, maybe increasing or decreasing. Then now what is the meaning of to shift the result in one direction? Then we'll talk about it later on. Very first we will discuss systematic. These errors tend to shift the result in the one direction, whether result will increase or whether result will be decreasing, right? Now the second thing is that the random error. So there is no known region of random errors. So random error occurs due to the unknown regions. If we are not knowing any particular region for the error, then that is in the category of the random error basically, right? Now these are the standard two types of the error. Now we are having some more types of the systematic error. Now in the systematic error, very first we are having instrumental error and second we are having the personal errors. So very first is the instrumental error. Now what is the instrumental error? Due to the defect in the instrument. Right? Now we can say that if there is any manufacturing error in the instrument, so that is in the category of the instrumental error, right? So very simple example, we can say that now we will talk about The types of the systematic error in this particular category, we are having instrumental error that occurs due to the defect in the instrument, or we can say if you are taking simple meter scale and after using repeatedly, if we are using that particular meter scale, so that will be worn from the one end. Then, so now if we are doing the measurement with the help of that particular meter scale, so what happens? There will that meter scale will gives us a some very decreasing value from the standard value. Very simple, if we can say, अगर आपके पास मीटर स्केल है, आप उसे रिपीटेडली यूज करते हैं, तो रिपीटेड यूज से क्या होगा, व्हाट हैपेंस, रिपीटेड यूज से क्या होगा, उसका वन एंड वन हो जाता है. And if one end is one, then what happens? If you are doing the measurement, then that will measure some lesser value than the actual measurement. तो वो क्या करेगा, आपकी जो मेजरमेंट होगा उससे थोड़ा सा लेसर वैल्यू को मेजर करेगा, बिकॉज उसका वन एंड एक्चुअली वन है, राइट. सो every time whenever you are using that instrument or that meter scale, so that will give you some lesser value than the actual measurement. So आप क्या करोगे, जब भी उससे मेजरमेंट करोगे तो हमेशा आपको थोड़ी सी लेसर वैल्यू देगी जो उसकी एक्चुअल वैल्यू होनी चाहिए. दैट मीन्स 1 मिलीमीटर 2 मिलीमीटर वो वन हो चुका है या 1 सेंटीमीटर वो वन है, तो वो हमेशा आपको लेसर वैल्यू देगा. तो ऑलवेज योर रिजल्ट इज शिफ्टिंग towards the decreasing order. Now you just understand, every time whenever you are just doing the measurement with the help of that instrument, what will you get? You will get some decreasing value. Right? Your result is always shifted in a decreasing direction. तो आपका रिजल्ट हमेशा क्या होगा, हमेशा थोड़ा सा कम होगा. तो वो किस डायरेक्शन में शिफ्ट हो रहा है, दैट विल बी शिफ्टिंग in one direction or the decreasing direction, right? अगर कोई भी इंस्ट्रूमेंट आपको हमेशा एक स्टैंडर्ड वैल्यू से ज़्यादा वैल्यू देता है, सो that result will be shifted in the increasing, right? So that will be instrumental error, meter scale one at the one end. This will be the example of instrumental error. Now we'll talk about the second type, that is the personal error. Personal error is something which occurs due to your own mistake, right? So that may happen whenever we are not holding any of the instrument in a correct way. So that occurs with due to our own mistake, right? So that will be in the category of the personal error. Now we can see that for suppose we are taking the reading of the thermometer from the thermometer, and we are not holding to read the reading in a correct manner. So what happened? Suppose it is below the horizontal line of sight. Suppose it is above the horizontal line of sight. So if it is below and above the horizontal line of sight, so that there will may be some error in the reading of thermometer, and that happens due to us because we are not holding that instrument, that thermometer correctly, right? So that error occurs in the category of the personal error, right, children? So this is somewhat about the types of the error and the simple definition of error. Now if we are talking about the errors, we are having some more types of the error. That means we are having least count error. Least count error is basically related to the instruments. What is least count? Basically the minimum measurement done by any instrument that is calculated as a least count, right? Suppose any instrument minimum measured 1 mm, so the least count of that instrument is 1 mm. Suppose it may measure 0.1 mm, so the least count of that particular instrument is 0.1 mm. So minimum measurement done by the instrument is defined as the least count, and if you are not calculating the least count correctly, so there may be some error in the least count of the instrument, and that may occur as in the category of the least count error, right? So in the same category, similarly we are having some more types of the error: absolute error, relative error, percentage error. Then now we'll talk about some more types of the error. So children, now we will just talk about some more types of the error, and in this particular category, very first we are having the absolute error. Now we just understand what is absolute error basically. Absolute error is the difference between individual measurement and the true value of the quantity. And What does it mean? That means if two value of the quantity is like one value, that is suppose 2.4 centimeter, and when we done the measurement, then we measured the value like 2.1, 2.2, 2.3. Right? So when we get the difference of the true value and the measured value individually, then we will get the absolute error. Right? So if we measured any quantity 4 times, so we will get 4 absolute error. If we measured any quantity 3 times, so we will get 3 absolute error. Now if we are doing the repeated measurement of any physical quantity and we are not having the true value of that particular physical quantity, so how will we calculate the true value? है सो अगर आपके पास डायरेक्टली मेजरमेंट है और आपके पास उसकी ट्रू वैल्यू नहीं है कोई भी, है ना, सपोज हम डायमीटर मेजर कर रहे हैं किसी वायर की और हमारे पास उसकी ट्रू वैल्यू नहीं है ना, राइट, और हम सिंपली मेजरमेंट करा हमने 4 टाइम्स 2.4 सेंटीमीटर 2.5 mm, सपोज mm में कैलकुलेट किया तो 2.4 mm 2.5 mm 2.6 mm 2.4 mm अगेन, तो हम क्या करेंगे ट्रू वैल्यू कैलकुलेट करने के लिए इन सारे मेजरमेंट्स का मीन कैलकुलेट करेंगे और जो मीन होगा that will be treated as a true value for that measurement, right? So difference between individual measurement and the true value of the quantity is defined as the absolute error and it is denoted by the mod of delta x. Mod of delta x. Mod, what is the meaning of mod? That means all the time measurement should be positive. So whenever we are doing the mod of any value, so that will gives us the magnitude of that value and magnitude is always taken as a positive, right? So whenever you are calculating the absolute error for different individual measurements and you are getting the negative value, so what you have to do, you will just mod of that value and you will get the positive value. So in conclusion we can say that absolute error is always positive, right? That cannot be negative. If you will get the negative value of the absolute error, just do the mod of that value and you will convert that value into the positive, right? Now suppose for the example, suppose any measurement done 4 times. If we done the measurement 4 times, then what happens? So if we are doing the measurement 4 times, so we will get the 4 absolute values of the error, right? So very first, so for the first measurement, so delta x1, mod of delta x1 will be equals to the x1 representing the first measurement, x1 representing the first measurement minus x mean. Now we are not having the true value, so what will we do to get the true value? We will just calculate the mean of all measured value. हमारे पास true value नहीं है तो हम क्या करेंगे, हम जितना भी हमने मेजरमेंट किया है 4 टाइम्स 3 टाइम्स और 6 टाइम्स उन सब का मीन कैलकुलेट करेंगे और वो मीन हमें ट्रू वैल्यू देगा, right? So this will be delta x1. Now delta x2, delta x3, delta x4. So delta x2, x2 minus x mean. Likewise delta x3, mod of delta x3, x3 minus x mean, right? And x4, delta x4, that means fourth absolute error will be equals to the x4 minus x mean, right? So if you have done the measurement 4 times, so you will get the 4 values of the absolute error, right? Now where in the condition, in this particular condition, x mean of all measurement is treated as the true value, right? So always remember that. Now the second type of the error is a mean absolute error. As by the name we can understand mean absolute error, that means mean of all absolute error. That means in a very first step, if we are getting the 4 absolute error, so we have to, in the next step we will calculate the mean of all 4 absolute errors. So that will give you the value of the mean absolute error, right? So mean of all absolute errors, like, so we can write down delta x mean equals to delta x1 plus delta x2, whatever measurement or whatever number of absolute error you are having, divided by the number of absolute error, 4, 5, whatever you are having, right? So that will give you the mean absolute error. Next, relative error. The next is the relative error. Relative error is a combination of above 2 errors. Like relative error is defined as the ratio of the mean absolute error, that means the second type of the error, divided by the mean of all measurement, that means mean of all observation of the measurement is x mean, right? So we can write down in the form of the formula delta x mean upon x mean. The ratio of these two values will give you the value of the relative error, right? Likewise, we can understand the fourth type of the error and the last type of the error, that is the percentage error. Percentage error, when we multiply a relative error by the 100, then that will give you the value of the percentage error. So we can write down percentage error equals to the relative error into 100%, or percentage error equals to, and what is the relative value of the relative error? Delta x mean upon x mean multiplied by the 100. Right? So at lastly, you can calculate if you are doing the measurement 4 times, 5 times. So what is the percentage error in that particular measurement, right? By this example, we will understand what all the steps and all the other types of the error, because all the other types of the error, these 4 types of the error are related to each other. If you are not having the value of the mean absolute error, so we cannot have a value of the percentage error. So step by step, if we want to calculate the percentage error, so step by step, very first we have to calculate absolute, then mean absolute, then relative, and lastly we will get the value of the percentage error, right? By the example, we will understand it. Suppose diameter of a wire is measured. Suppose diameter of a wire is measured like 2.04 mm, 2.06 mm, 2.707 mm, 2.08 mm, 2.5 mm, 0.5 mm. Now what we have to calculate? Find the percentage error in the measured diameter. आपने ये जो आपके पास वायर की डायमीटर थी, आपने 5 टाइम्स मेजर की, तो आपको बताना है कि इन 5 टाइम्स जब आपने मेजर करी तो टोटल इसमें कितना परसेंटेज एरर आया, कितने परसेंट का एरर आया, 2% का आया, 3% का आया, 4% का आया. आप जितना एक्यूरेट करोगे परसेंटेज एरर की वैल्यू उतनी ही कम होगी. आप जितना एक्यूरेसी से नहीं करोगे मेजरमेंट तो परसेंटेज एरर उतना ही हाई होगा, राइट? नाउ अगर हमें परसेंटेज एरर कैलकुलेट करना है तो हमें व्हाट वी नीड? रिलेटिव एरर. नाउ इफ वी वांट टू कैलकुलेट द रिलेटिव एरर, देन व्हाट वी नीड? Absolute, mean absolute error and x mean. Now mean absolute error, for mean absolute error what we need? Individual absolute error. So we'll start from very first absolute error. So to calculate the absolute error calculate करने के लिए अगर हमारे पास 5 मेजरमेंट है तो हमारे पास 5 absolute errors होंगे, राइट? तो absolute error calculate करने के लिए आप क्या करोगे? फर्स्ट ऑब्जर्वेशन माइनस ट्रू वैल्यू. अब ट्रू वैल्यू कैसे कैलकुलेट होगी? तो हम क्या करेंगे, इन सबका मीन कैलकुलेट करेंगे, दैट इज x mean equals to 2.04 plus 2.06 plus 2.07 plus 2.08 plus 2.05 divided by 5. आप जब इन सब का मीन करेंगे then you will get 2.06 mm. This will be the mean. Now you can get the value of the absolute errors. So delta x1 equals to x1 minus x mean. Right? So delta x1 equals to first mean absolute error कितना हो जाएगा? x1 minus x mean. तो what is the value of the x1? 2.04 mm minus, and what is the value of x mean? 2.06 mm. Right? So you will get the value. आपके पास वैल्यू आएगी माइनस 0.02 mm, और वो आपके पास मॉड ऑफ है तो वो वैल्यू प्लस में कन्वर्ट हो जाएगी, तो यू विल गेट 0.02 mm. Likewise, you will calculate delta x2, delta x3, delta x4, delta x5. You will just calculate these all values with the help of the formula. Right now I'm just writing the direct values of these values because we are not having very much more time. So second will be 0, you will get 0 mm. Third you will get for the third you will get 0.02 mm. For the fourth you will get 2.06 mm minus 2.07 mm, and you will get 0.01 mm. Likewise, x5 you will get 2.05 mm minus 2.06 mm, and you will get like 0.01 mm. So you will get 0.02 mm. For the next you will get 0 mm. For the next you will get 0.02 mm, next you will get 0.01 mm, and the next you will get 0.01 mm. Order you can change. Then, so that is not if you are writing this value at the very first, so this will be very first absolute error. You can change the order likewise. So we will get 5 absolute error. Now in the next step we will calculate the mean absolute error. That means the delta x mean. So that will be the mean of all absolute errors. So mean of all absolute errors means 0.02 plus 0.00 plus 0.02 plus 0.01 plus 0.01 divided by 5. Right? So when you will do this calculation, you will get 0.012 mm. Then this is mean absolute error. Nextly we will calculate relative error. Relative error. For relative error, what will we do? 0. Mean of all absolute error, delta x mean divided by x mean. So delta x mean 0.012 mm divided by, and x mean is 2.06 mm. So when you divide both quantities, so you will get 0.058 mm. 0.0058 only. Mm will be cancelled from each other and you will get 0.0058. Right? And likewise in the last step you will get the percentage error, and percentage error you will get when relative error will be multiplied by the 100%, and this will be 0.0058 multiplied by the 100, and you will get the answer like 0.58%. So 0.58% will represent the total percentage error in the measured values. Right? So this is a sample example related to the all 4 types of the errors. So with the help of examples, you can understand all the steps of all the type of the errors. So children, so that's all for today. Thank you so much.